Hi and welcome to this segment where we are going to look at the backward difference operator, and we are going to represent it with the symbol del. Okay, so now we are going to say that for the values y0, y1, y2 and so on up to yn of the function y equals to f of x, okay, for equidistant points x0, x1, x2 and so on up to xn, where x1 is given by x0 plus h and x2 is x0 plus 2h, x3 is x0 plus 3h and so on, and xn is x0 plus nh. In other words, h is the step length here. Okay, the backward difference operator denoted by del is going to be the function defined as, okay, f of xi, the backward difference operator is f of xi, which is going to be given by f of xi minus f of xi minus h. Okay, by definition, last time we said that this is the same as yi minus yi minus 1. In other words, as a simple illustration, okay, we can consider this as the point xi, okay, and this is at the point xi plus h, and then this is the point xi minus h. This is yi, okay, this is yi plus 1, and this is yi minus 1. So for the backward difference operator defined at f of xi, okay, of course we know that this is f of xi, this is f of xi plus h, and this is f of xi minus h. So the backward difference operator at which is at f of xi is going to be given by f of xi minus f of xi minus h. So we stand here for the backward difference operator and then we subtract the one before. Remember last time we said that for the forward difference operator at the same point here, it is going to be given by f of xi plus h minus f of xi. Okay, just as a reminder here for those of you who may have forgotten, we are going to write the forward difference operator, that is delta f of xi is f of xi plus h minus f of xi, which we said is the same as yi plus 1 minus yi. This was just a simple reminder. Okay, alright, now if we get back to our backward difference operator, so here we can now say that in particular we can say that the backward difference operator of f of x1 is going to be given by y1 minus y0. Okay, we can say that it is f of x1 minus f of x0, okay, which will give us this. Then the backward difference operator at x2 is going to be given by y2 minus y1. Okay, so what about the second backward difference operator? By definition, we shall write it as the second forward backward. Did I say second forward? Oh no, I'm sorry. The second backward difference operator, okay, which can be written as the backward difference operator, the backward difference operator of at f of xi. So by definition, we know that what is inside the brackets here is given by f of xi, okay, minus f of xi minus h. Okay, so now we have, this is the backward difference operator at f of xi minus the backward difference operator at f of xi minus h. Again, by definition, this one here we know is going to be given by f of xi minus f of xi minus h, then minus, so this one here by definition is going to be f of xi minus h minus f of xi minus h minus h, okay, which is going to be f of xi minus 2h. So we can open the brackets and then say this is going to be f of xi minus f of xi minus h minus f of xi minus h minus, oh sorry, this is going to be now plus f of xi minus 2h. Okay, so we know that we can write this as yi minus this one here is yi minus 1 minus yi minus 1, okay, and then plus yi minus 2, okay, and then yeah, finally we can write it as yi minus 2 yi minus 1 plus yi minus 2. So this is the second backward difference operator. So someone in the comments asked that where are these used. So these are very important, by the way, especially in the numerical approximation of differential equations. So you will notice there are some approximations to differential equations, okay, which we shall later on see: first order, second order, backward, or first order, and then quite a number. Okay, I don't want to preempt so many things, but these backward or forward difference operators are used in approximating some of these differential equations, okay, in the numerical approximations of some of these differential equations, which are again important in writing numerical algorithms, which can be transferred into computer code, which can be simulated, and then you really get very nice things that come up. Okay, so if there is some bit of motivation, you can also check on the internet and then see. It is quite clear, the applications of these backward and forward difference operators which we are dealing with here. Okay, yes, so we are later on, of course, now we are running out of time, so I would like you to verify what is in the lecture notes, that actually using the same procedure which we have gone through to write this expression, I would like you to verify that the third backward difference operator, okay, over fx at f of xi, okay, is going to be given by yi minus 3 yi minus 1 plus 3 yi minus 2, okay, then minus yi minus 3. If I haven't made a mistake, I hope that's it. So I would like to conclude this video here by looking at the backward difference table. Okay, very similar to what we did for the forward difference table, so I will go through this quite fast. Okay, so we'll have a column where we have our x, and then we have a column where we have our function values, then we have a column for the first backward difference operator, we have a column for the second backward difference operator, and then we shall stop on the third backward difference operator. Okay, so what do we have in here? We have here that we have the values of x, okay, we have the values of x, okay, In other words, we have x0, then maybe we have x1, then we have x2, maybe we have x3, and then we have the values of y. Y is given by f of x. Okay, so this is y0, which is equals to f of x0, and then this is y1, which can be written as f of x1, and so on. So I'll just write y2 here, and then I will write y3 here. So we have the first backward difference here. Okay, so this is going to be the first backward difference operator, okay, at y1, which is the, but if we can write it as f of x1. Okay, and we have said that this is going to be equal to y1, okay, this value here, minus y0, the value here. Okay, in other words, f of x1 minus f of x0. So for now, just allow me to write that here. We shall have the first backward difference operator at y2, which is simply going to be y2 minus y1, and then this is the first backward difference operator at y3, which is going to be y3 minus y2. Okay, so this one here is the second backward difference operator. So here we're going to define the second backward difference operator at y2 here, which is simply going to be given by the first forward difference at y2 minus the first forward difference at y1. And then what do we have here? The second forward difference at y3 is going to be equal to the first forward difference at y3 minus the first forward difference at y2. And then this is the third backward difference operator. So the third backward difference operator, evaluated here at y3, is going to be given by the second forward difference, okay, at y3 minus the second forward difference at y2. Okay, so I hope you have been able to pick a thing or two here. If you have any questions, you can put them in the section. So see you in the next video.